Good morning, students. It gives me great pleasure to talk to students through video presentations like this. The topic which I have chosen today is integration as limit of a sum. Before going into the problems directly, I'll just get you the proof for that in an easy manner. Just listen carefully. Before going into those details, by integral a to b f of x dx, we mean the area of the region bounded between the line x equal to a, the curve y is equal to f of x, the line x is equal to b, and x-axis. I can even draw over here. This is my line, let us say x is equal to a. This is my curve, y is equal to f of x. This is my line, x is equal to b. And this is my x-axis anyway. This is x-axis I have drawn. Okay, I repeat, just integral a to b f of x dx. By this I mean it is this area. Okay, this is the area which I am going to find out. Okay, area of the region bounded between line x equal to a, the curve y equal to f of x, line x is equal to b, and x-axis. Okay, how to get this with some formula? Let us just see. This method is called limit of a sum. Let us say, just listen. What I will do is, this point is anyway a, this point is b. You know very well a comma 0. And therefore, this length is automatically b minus a. I will divide it into n equal parts, let us say. I will just divide it into n equal parts, each of with, let's just say, h is equal to b minus a by n. I just repeat, this point is a comma 0, everybody knows. This point is nothing but b comma 0. Therefore, this length is nothing but b minus a. This length is b, this length is a, therefore this will be b minus a. I'll divide this length b minus a, each of width h is equal to b minus a by n. What I will do is, actually I'll be able to having various such smaller, some kind of trapezium like things you may just imagine over here. Area is divided into n such smaller areas, practically speaking. What I will do is, I'll allow my n to tend to infinity. I'll allow my n to tend to infinity is equivalent to h tends to 0. When h is tending to 0, each of the smaller areas will become smaller rectangles, infinitely many such rectangles. I repeat, this point is a comma 0, this point is b comma 0. Therefore, this width is nothing but b minus a. Therefore, this length or width, whatever it may be, this portion b minus a is divided into n equal parts. Each of width is equal to h is equal to b minus a by n. I think it's clear to you. Okay, now I'll allow my n to tend to infinity. Okay, therefore h will tend to 0. When h tends to 0, then each of this smaller areas will become smaller rectangles. I'll get infinitely many rectangles. Therefore, the whole area now a to b f of x dx now becomes the limiting value of n tends to infinity, h tends to 0 of sum of all those rectangles which I am going to consider. But in each of those rectangles, my width is nothing but h. Okay, my height varies from, if I take from the leftmost value, it will be f of a plus f of a plus h plus etc f of a plus n minus 1 into h I will have. Or I will have it to be limit h tends to 0, n tends to infinity of h into, the sigma I will write later. If I take from the rightmost n, the first point will be f of a plus h. This is f of a plus 2h plus etc. The last one will be f of a plus nh. A plus nh is nothing but b anyway. F of b, f of a plus nh both are same. I can write this in sigma notation also. Limit h tends to 0, n tends to infinity of h into sigma k equal to 0 to n minus 1 of f of a plus kh. Or it is limit h tends to 0, n tends to infinity of h into, this is sigma k is equal to 1 to n f of a plus kh. Let me repeat the whole process. I already told you integral a to b f of x dx is the area of the region bounded between the line x is equal to a, the curve y equal to f of x, line x is equal to b, and x-axis. Now this point is small a comma 0, this point is small b comma 0 being points on x-axis. Now this width will be automatically b minus a. I'll divide this with b minus a into n equal parts. Each of width is equal to h is equal to b minus a by n. I allow my n to tend to infinity, therefore automatically h tends to 0. Therefore, the smaller areas, n areas what I am going to get, when n tends to infinity, h tends to 0, each of those smaller areas will be divided into infinitely many smaller rectangles. Therefore, the whole area is nothing but the limiting value of some of those areas of the rectangle. That is the meaning, practically speaking. And in each of those rectangles, width is nothing but uniformly h. Height varies from the point over here, this height over here, which I am going to choose over here. If I take from the leftmost value, it will be f of a, next one is f of a plus h, and the last one will be f of a plus n minus 1 h. And if I take from the rightmost value, it will be f of a plus h plus f of a plus 2h, etc. f of a plus nh. I can write the same thing in terms of sigma notation as limit h tends 0, n tends to infinity, h into sigma k equal to 0 to n minus n f of a plus kh, or limit h tends 0, n tends to infinity, h into sigma k equal to 1 to n f of a plus kh. That is the meaning. You may wonder, how is it possible to have it as to be equal? Here I choose only 0 to n minus 1, here I choose only from 1 to n. Anyway, n is tending to infinity. Whenever n is tending to infinity, n minus n is also tending to infinity. Therefore, both the equations or both the values are the same, and therefore it is always suitable for you to choose the second one, because here I'll be using almost 5 formulae, namely sigma 1 k equal to 1 is n. Sigma k equal to 1 to n, sum of first n natural numbers, which is n into n plus 1 by 2. Sigma k square, k equal to 1 to n, sum of squares of first n natural numbers, which is n into n plus 1, 2n plus 1 by 6. And sigma k cube, which is sum of cubes of first n natural numbers, k equal to 1 to n, here it will be n square into n plus 1 whole square by 4. And fifth one is the GP formula, a plus ar plus etc. a r power n minus 1 is a into r power n minus 1 by r minus 1. These are the 5 things which will be very useful for such a problem. And using this formula and finding this area is equivalent to finding this, definite integral problem is supposed to be limit of a sum, method of limit of a sum. Anyway, I'll just move on to the problems. I'll take a simple example. I'll take simple x category. Okay, simply x I will take. I'll take x square, and I'll grouping x square and x together. I'll take an exponential function. Then I'll just wind off. Just listen carefully. Okay, let me make it into 2 halls over here. Just listen carefully. Evaluate integral 0 to 5 x dx as a limit of a sum, let us say. Limit of a sum, let us say. Okay, here my lower limit a is 0, my upper limit b is 5, my h happens to be b minus a by n, therefore this is 5 by n. Okay, now my functional value f of x is x, therefore integral 0 to 5 x dx, I will write it as integral a to b f of x dx. Now, just now I derived the formula limit h tends 0, n tends to infinity of h into sigma k equal to 1 to n f of a plus kh. You can very well say this is by formula. This is the formula to be applied anyway. This is limit h tends to 0, n tends to infinity of h into sigma k equal to 1 to n f of kh, since a is 0. Okay, this is limit h tends to 0, n tends to infinity of h into, this is sigma k equal to 1, f of x is x given, therefore this is kh. Therefore this is reduced to anyway. I'll take h out. Okay, the summation is only with respect to k. This is limit h tends to 0, n tends to infinity of h square into sigma k equal to 1 to n. Therefore, this is equal to limit h tends to 0, n tends to infinity of h square into, this is nothing but sum of first n natural numbers. This is anyway n into n plus 1 by 2, let us say. Therefore, this is limit n tends to infinity, let us write. I'll replace h by 25, h square becomes 25 by n square, n into n plus 1 by 2. Let me take 25 by 2 as common. I'll end up with limit n tends to infinity, 1 n gets cancelled. I'll divide like this, n by n plus 1 by n. Therefore, this is reduced to 25 by 2 into limit n tends to infinity of 1 plus 1 by n. Therefore, this is 25 by 2 into 1 plus 0. When n tends to infinity, 1 by n tends to 0. Therefore, this is reduced to simply 25 by 2. I can easily verify the answer 0 to 5 x dx, which is x square by 2, 0 to 5. Apply the upper limit, 25 minus by 2. Apply the lower limit. Therefore, it is reduced to 25 by 2. Let me repeat the whole process. Here my a is 0, lower limit. B is 5, which is my upper limit. Then h is b minus a by n, which is 5 by n. F of x is nothing but x. Now I'll write in terms of a to b f of x dx. This is the formula. Limit h tends 0, n tends to infinity, h into sigma k equal to 1 to n f of a plus kh. Limit h tends 0, n tends to infinity, h into sigma k equal to 1 to n f of kh, because a is 0. F of x is x, f of 4 is 4, f of 7 is 7, f of 10 is 10, therefore f of kh is kh. This is h square sigma k. Now sigma k is n into n plus 1 by 2. H is 5 by n, therefore h square is 25 by n square. 1 n gets cancelled. Till then I have h as well as n, I will write both. Here I am replacing h in terms of n. I will retain n tends to infinity. I'll take away h tends to 0. Then 25 by 2 into limit n tends to infinity. N by n is 1 plus 1 by n. 1 by n tends 0 and n tends to infinity. Therefore, this is reduced to 25 by 2. How to verify the answer? X square by 2, 0 to 5. Apply the upper limit, 25 by 2 minus 0 by 2. My answer 25 by 2 is correct. I think it is clear to everybody. Let me take another example. Let me just take another example. Okay, I'll take one more example. Just listen carefully. It's not a difficult task to follow. You should know what the value of A is, what the value of B is, what f of x is, what h is. Then write the whole problem in terms of a to b f of x dx. Then write the formula with respect to limit, etc. Then substitute the value of a. Then substitute the functional value. Then replace wherever you come across sigma 1, replace it as 1, n, sorry. Then wherever you come across sigma k equal to 1 to n, write it as n into n plus 1 by 2. Wherever you come across sigma k square k equal to 1 to n, write n into n plus 1 to n plus 1 by 6. Wherever you come across sigma k cube k equal to 1 to n, replace it as n square into n plus 1 whole square by 4. And wherever you come across the formula to be applied in terms of GP, write the formula a into r power n minus 1 by r minus 1. That will be applicable when you have an exponential problem. Let it be. Let me take another example. Let me just take another example. Okay. For a change, let me take integral, lower limit is other than 0, 1 to 3 x square plus 6 dx, let us say. Now here a happens to be 1, b happens to be 3, h is b minus a by n, which is 2 by n. My f of x is x square plus 6, let it be. Now integral 1 to 3 x square plus 6 dx. I write it as integral a to b f of x dx, let us say. Therefore, this is limit h tends to 0, n tends to infinity of h into sigma k equal to 1 to n f of a plus kh. This is the formula. By formula, you can very well write. By formula, this is equal to limit h tends to 0, n tends to infinity of h into sigma k equal to 1 to n. This is f of the, write the value of a. This is f of 1 plus kh. since a is equal to 1. I'll write the value of a also here. This is limit h tends to 0, n tends to infinity of h into sigma k equal to 1 to n. Now f of x tells you square the value plus the value. F of 2 is 2 square plus 2. F of 7 is 7 square plus 7. F of 1000 is 1000 square plus 1000. Therefore, f of 1 plus kh is 1 plus kh the whole square plus 1 plus kh. Let it be. Let me just expand. This is limit h tends to 0, n tends to infinity of h into sigma k equal to 1 to n, 1 plus k square h square plus 2kh plus 1 plus kh, let it be. Let me start writing from the highest power. Therefore, I will have h into sigma k equal to 1 to n. This is k square h square plus 3kh plus 2. I think it is clear to you. Now, therefore, this is reduced to limit h tends to 0, n tends to infinity of h cube into sigma k square k equal to 1 to n. Okay, plus 3h square into sigma k equal to 1 to n plus 2h into sigma 1 k equal to 1 to n. I think I am right. H cube into sigma k square plus 3h square into sigma k plus 2h into sigma 1. Therefore, this is equal to limit h tends to 0, n tends to infinity of h cube into this formula is n into n plus 1 into 2n plus 1 by 6, let it be. Okay, plus 3h square into this is n into n plus 1 by 2. Then plus 2h into n, let us say. Now, therefore, this is anyway reduced to limit n tends to infinity. I am returning n tends to infinity because I am going to replace h by 2 by n. Therefore, this is 8 by n cube. 8 by n cube into n plus 1 into 2n plus 1 by 6 plus 3 by 2 into this is anyway 4 by n square into n plus 1 by 2, then plus 2 into nh is anyway 2, let it be. This 4 anyway gets cancelled. Here it is 4 2's, this is 3 2's. Therefore, this is reduced to limit n tends to infinity of 4 by 3 into, I will divide 1 n by this, I will divide 1 n with this. Okay, then I'll end up with 3 into, I'll have 1 plus 1 by n plus I end up with 4. Therefore, this is 4 by 3 into 1 plus 0 into 2 plus 0 plus 3 into 1 plus 0 plus 4. Therefore, this is reduced to 8 by 3 plus 7. 7 3's are 21. 8 plus 21 by 3. Therefore, this gets reduced to 29 by 3. 29 by 3. Therefore, let me just check the answer. Integral 1 to 3 x square plus 6 dx. Okay, now I'll write this as x cube by 3 plus x square by 2, 1 to 3. Let me apply the upper limit. What do I get? 27 by 3 plus 9 by 2 minus 1 by 3, okay, minus 1 by 2, let us say. Now 27 minus 1 happens to be 26 by 3. Then this is anyway by plus, this happens to be 9 minus 1 is 8. 8 by 2 is 4. Something is wrong. I have to check the answer anyway. X cube by 3 plus x square by 2. This is 27 by 3 plus anyway 9 by 2 minus 1 by 3 minus 1 by 2. It's correct. Now 26 by 3. Anyway, this is, yeah, it's correct. 26 by 3 plus 4. Let me check whether my answer is correct over here. 4 by 3 into 1 plus 0 into 2 plus 0 plus 3 into 1 plus 0, it's correct, plus anyway 2 2's are 4, let us say. 8 by 3 plus 3 plus 4 is 7. Therefore, this is reduced to 29 by 3. My answer is correct only here. Let me start doing from the beginning. Whether I am going wrong elsewhere, let us see. Let me check from here. H sigma k equal to 1 to n f of 1 plus kh. It's correct because my a is 1. H sigma k equal to 1 to n, limit h in 0 n tends to 1 plus kh whole square plus 1 plus kh. It's correct. 1 plus k square h square plus 2 kh plus 1 plus kh. Now for k square h square plus 3 kh plus 2. 1 plus 1 is 2. It's correct. H cube sigma k square plus 3h square sigma k plus 2h into sigma 1. Let it be. It's correct. Now this is n into n plus 1 2n plus 1 by 6 h cube into plus 3h square into n into n plus 1 by 2 plus 2h into n. It's correct. Therefore, here I am replacing h by 2 by n. Now for 8 by n cube into n plus 1 2n plus 1 by 6 plus 3 by 2 into 4 by n square into n into n plus 1 by 2. This 4 gets cancelled anyway. Plus 2 into this n h is replaced by 2. Therefore, 4 2s are 8, 3 2s are 6. It's correct. 4 by 3 into 1 plus 1 by n, 2 plus 1 by n, plus 3 into 1 plus 1 by n, plus 4. It's correct only. When n tends to infinity, 1 by n tends to 0. Therefore, 4 by n into 1 plus 0 into 2 plus 0, plus 3 into 1 plus 0 plus 4. Therefore, 4 2s are 8, 8 by 3. This 3 plus 4 happens to be 7. 7 3s are 21. 29 by 3 is the correct answer. Now, x cube by 3 plus x square by 2, 1 to 3. Upper limit is 27 by 3 plus 9 by 2 minus 1 by 3 minus 1 by 2. 27 minus 1 is 26 by 3. 9 minus 1 is 8. 8 by 2 is 4. 4 3s are 12. Where am I going wrong? I don't think anything is wrong over here. 1 to 3 x square plus x dx. This is x cube by 3 plus x square by 2. Upper limit 27 by 3 plus 9 by 2 is correct. Minus 1 by 3 minus 1 by 2 it's correct only. 27 minus 1 is 26. 26 by 3. 9 minus 1 is 8. 8 by 2 is 4. Therefore, finally 4 3s are 12. 26 plus 12, 38. Where am I going wrong? Something is wrong. How to check the answer? How to check the answer? We need to check somewhere else. Where I am going wrong, I need to check. Okay. Anyway, I don't think it's wrong. You check the checking part anyway. Yourself, you just see. Let me just go through the whole lot once again. 1 plus k square h square plus 2 kh plus 1 plus kh is correct. K square h square plus 3 kh plus 2 it's correct. H cube sigma k square. 3h square sigma k it's correct. 2h sigma 1 is correct only. H cube into n into n plus 1 2n plus 1 by 6 plus 3h square into n into n plus 1 by 2 it's correct. Plus 2h into n it's correct. That is 8 by n cube in n into n plus 1 2n plus 1 by 6 plus 3 by 2 into 4 by n square into n into n plus 1 by 2 plus 2 into 2. It's correct. 4 by 3 into 1 plus 1 by n into 2 plus 1 by n. Okay. Plus 3 into 1 plus 1 by n plus 4. It's correct. 4 by 3 into 1 plus 0 into 2 plus 0. Okay, plus 3 into 1 plus 1 by n plus 4. It's correct only. 4 by 3 into 1 plus 0 into 2 plus 0 plus 3 into 1 plus 0 plus 4. This 3 plus 4 is 7. Taking LCM, 7 3s are 21. 21 plus 8 is 29 by 3. I don't think anything is wrong over here. Okay. Anyway, I want you guys to do once again and check the answer anyway. I am not going wrong elsewhere. Okay. Anyway, due to time constraints, let me just stop here. Okay. I'll do with an exponential case. Okay, I'll do with an exponential case, okay, in the next video. Thank you very much for patient watching. Thank you. In the previous problem, I have identified error what the mistake is. I'll just do from the middle of the case. Actually, the problem goes like this. This is limit h tends to 0, n tends to infinity of h into, I mean to say it is k equal to 1 to n. This is 1 plus kh the whole square plus 1 plus kh. From this part, I'll just continue. This is limit h tends to 0, n tends to infinity of h into sigma k equal to 1 to n. This is anyway 1 plus k square h square plus 2 kh plus 1 plus kh, let it be. Therefore, this is limit h tends to 0, n tends to infinity of h into sigma k equal to 1 to n. This is k square h square plus 3 kh plus 2, let us say. Therefore, this is anyway limit h tends to 0, n tends to infinity of h cube into sigma k square k equal to 1 to n plus 3h square into sigma k equal to 1 to n plus 2 sigma 1 k equal to 1 to n. Therefore, this is reduced to limit h tends to 0, n tends to infinity of h cube into n plus 1 into 2n plus 1 whole by 6 plus 3h square into n plus 1 by 2 plus 2hn, let us say. There is one more h here, sorry, 2h. Therefore, this is reduced to limit n tends to infinity of 8 by n cube into n plus 1 into 2n plus 1 by 6 plus 3 by 2 into 4 by n square into n plus 1 by 2. Here I have made a mistake. That 2 is taken out and I have written one more 2 over here in the previous case. Just sorry. And this is anyway 2 into 2. This is 2 into 2. Your NH is 2 anyway. Therefore, this is reduced to anyway limit n tends to infinity of 4 by 3 into 1 plus 1 by n into 2 plus 1 by n. This is anyway, this reduced to 6 anyway. Only 1 2 gets cancelled. The previous case I took one more 2 in the denominator. That is a mistake which I made. Sorry. I am extremely sorry. 1 plus 1 by n plus this is anyway 4. Therefore, this is reduced to 4 by 3 into 1 plus 0 into 2 plus 0 plus 6 into 1 plus 0 plus 4. Therefore, this is reduced to 8 by 3 plus 10. Therefore, this reduced to 38 by 3. Now, normal integration tells you x cube by 3 plus x square by 2, 1 to 3. This is 27 by 3 plus 9 by 2 minus 1 by 3 minus 1 by 2. Therefore, 27 minus 1 by 3 plus 9 minus 1 by 2, which is 26 by 3 plus 4. This is again 38 by 3. Sorry, I made a mistake by writing one more by 2 over here, the previous case. Please make the correction and learn. And the answer here is 38 by 3. It gets tallies with the one tallied with what I have done, the direct method. Okay, I'll try to see to it such mistakes won't happen further. Thank you very much. Thanks for patient watching. Thank you.